Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In the series of lecture concerning the course Applied Pharmacy, which is designed for fifth year pharmacy student, we speak in this fifth lecture about preliminary quantitative determination of active ingredients that present in vegetable drugs. Preliminary quantitative determinations means the use of physical and chemical method to determine the quantity or the concentration of active ingredient present in powdered plant sample. Quantitative determination having two main objectives can be considered as useful tool for drug discovery, and the another importance is considered as useful tool for standardization of herbal drugs or inquired control of herbal drugs. As we know, for drug discovery, it is a tedious process involving several steps, which each step requires time and cost. So, before we proceed to the highest level for isolation of active ingredient, we need to perform a simple quantitative or general quantitative determination to assess the quantity of active ingredient present in plant sample. Also, the importance of quantitative determination in quality control of herbal drugs is that quantitative determination can give an as considered as indicator to predict which type of treatment the herbal drugs is exposed from cultivation until it reaches the manufacturer. Means which type of condition the drug is exposed to during this post-harvesting process. One of the drawbacks of quantitative determination is that the error in calculation of active ingredient may due to interference between the active ingredient present in plant sample. For example, when we decide to determine the alkaloid in plant sample, alkaloid having the same nature, chemical physical nature to some proteins. So it is difficult to determine the alkaloid concentration or quantity without or avoiding the protein present in the sample. There are several methods used for quantitative determination of herbal drugs. One of them is, or the first of them is using of simple calculation by determining the yield percentage. This means dividing the weight of sample, the weight of extract to the weight of original sample. The another method is using gravimetric titration, and the third method is using volumetric titration, and the fourth one is using colorimetric titration. As we know, gravimetric titration means using formation of precipitate and determining the amount of the quantity of this precipitate. And for volumetric is determining concentration of active ingredient. While colorimetric assay depend on the using of UV spectroscopy to determine the quantity of colored precipitate formed in the extract. The content of this lecture can be divided into two sections. The first part we give some information about the type of method used for quantitative determination, and in the second part we take example for each method used in quantitative determination. For gravimetric titration, we talk about uh, some important class of secondary metabolites, including alkaloids, flavonoids, saponins, and lipids. For volumetric titration, we talk about one example, determination of cyanogenic glycosides, and in colorimetric, we speak about determination of total phenol. It is worth mentioning that there is a difference between quantitative determination of isolate and quantitative determination of plant sample or vegetable drugs. For example, quantitative determination for powder sample drug, we can speak about bicarbonate route, can be determined by using volumetric titration, while for imethine as isolate from epicarb can be determined by a spectroscopic analysis. Another example, quantitative determination of colchicum corn, which contain colchicine, can be determined by gravimetric titration, while colchicine as isolate can be determined by spectroscopic analysis. In introduction, we need quantitative determination to aid the process of drug discovery, and drug discovery is a tedious and lengthy process which consists of several steps that end with isolation of the bioactive compound present in sample. So the importance of quantitative determination is to decide or determine the quantity. Is it present a sufficient level to proceed to the next level of isolation, because each process is lengthy and it is costly. So the importance of quantitative determination is to ease the process of drug. In general, quantitative analysis or general quantitative analysis is considered as useful tool to determine the quantity and concentration of active ingredient that present in plant sample. When we compare qualitative analysis to qualitative analysis, we find that quantitative analysis is comprehensive process that gives insight of the concentration or quantity of secondary metabolite present in sample, with the end aim that to, to aid the drug discovery process or to standardize herbal drugs. There are several methods used in quantitative determination of the active ingredient. The simplest method or the simplest approach is by using or by weighing the amount of initial plant material used and the amount of extract obtained, which is known as yield or as residue. We can calculate from a fresh sample or dry sample. So to calculate a yield percent, we first need to determine the yield, amount of yield in gram by subtracting the weight of extract obtained from the weight of initial dried or fresh material used. And the second step to determine the yield percent weight per weight, we divide the extract obtained or weight of extract obtained to the weight of initial dried material. If we use fresh tissue containing moisture, for example, drug from leaf contain 90% water. To calculate the yield percentage for fresh tissues, we need conversion factor to separate the result as percentage of dry weight. The general quantitative determination of active ingredient is carried out on dried powdered material to determine, or sometimes from fresh material to determine the total content of active ingredient. The aim of general quantitative determination is determine total content of active ingredient. As we know, active ingredient including uh, sugars, tannins, alkaloids, and so on. But this procedure having drawbacks or sometimes reliable to error. The reason of this error due to interference of this component. For example, interference of alkaloid with proteins because they have similar chemical properties. But it is still valuable for two, uh, uh, two importances or two aims. One of them is for drug discovery, and the second for standardization of herbal drugs. So it predicts the growth condition which the plant organ exposed, such as the pathogen, as we know, when exposed to a plant exposed to pathogen may reduce the quantity of active ingredient. It is worth mentioning that the general quantitative method used for vegetable drugs or dialytical preparations are different from that of pure isolates. For example, assay for Ivicac root is different from its isolate imitin. For Ivicac powder, we use aqueous volumetric titration, and while for imitin we use spectroscopic or spectrophotometric method of non-aqueous titration according to BB and USP. Another example is assay of colchicum powder, which contain colchicine as isolate. The colchicum powder can be determined, or the quantity of colchicine in colchicum powder determined by gravimetric titration, while for colchicine as isolate can be determined by colorimetric or spectrometric analysis. So there are different methods for can be used in analysis of active ingredient. Example of quantitative method used in determination of active ingredient in general is gravimetric assay, which can be used for determination of caffeine in tea powder or colchicine in colchicum corn powder. Another example for quantitative method is the use of volumetric aqueous titration to determine atropine in hyoscyamus muticus powder. And another example, the use of volumetric aqueous titration to determine emitting in Ibicac or Ipicona route. The third example of quantitative method is the use of non-aqueous titration. And for example, the determination of ephedrine is in its natural sources and other pure alkaloids. Also, colorimetric assay can be used to determine the ergot alkaloid and total phenol. And these four methods, gravimetric assay, volumetric for non-aqueous titration, gravimetric can be used for vegetable drugs or for diurnal preparations. For isolate, we use spectroscopy, for example, determination of colchicine isolate, and volumetric assay for determination of canine, and also use of other chromatographic assays like HPLC, TLC to determine isolate of active ingredient. The main difference between gravimetric assay and volumetric assay is that gravimetric is used to determine the mass of active ingredient by formation of precipitate, while volumetric titration also is quantitative method to determine the concentration of unknown active ingredient or substance present in solution. And generally, by using or reacting the solution with known concentration of uh, sample or non-sample until its end point. And an end point can be indicated by changing color uh, as indicators. For volumetric assay, we take 5 examples for important class of secondary metabolites, including alkaloid, flavonoid, lipids, saponins, and steroids. And for volumetric, we speak about or describe one example or determination of uh, one class of secondary metabolite اللي هي cyanogenic glycosides. For volumetric titration, there are several examples, including compleximetric titration, used to analyze metals, ion in solution, and precipitation titration, which based the formation of precipitate during reaction, and redox titration, which involve oxidation reduction reaction, and acid-base titration, which involve retain the concentration of acid or base. To determine the quantity of alkaloid present in plant sample by gravimetric methods, we need the following. First, we need 5 grams of powdered sample containing alkaloid, and then we add to this sample 250 ml of 10% acetic acid in ethanol and allow to stand for 4 hours. Then we filtrate the extract and concentrate on water bath to its 1/4. Then to filtrate, we add concentrated ammonium hydroxide to filtrate until the precipitate is formed, and after formation of precipitate, we collect the precipitate after combination settles in the beaker. We repeat the process of addition of ammonium hydroxide, and then in this step we add ammonium hydroxide dilute solution. Then we filter and we collect the filtrate. This considered filtrate containing alkaloid extract. We dry this extract and we weigh it. Calculate the weight of percentage of alkaloid present in the sample. We divide the weight of alkaloid obtained, which equal the weight of the weight of paper and filter paper and alkaloids, minus W1 and the weight of empty filter paper. Then we find the yield or the quantity of alkaloid precipitate. This value, W2 minus W1 divided by the weight of original sample, here 5 grams in this example, and multiplied by 100, we obtain the weight of alkaloid. So, in general, for determination of alkaloids, we need powder sample, then we react the sample of extracted with 10% acetic acid in ethanol, then we filtrate and concentrate in water baths. We add ammonium hydroxide as reagent to formation of precipitate. We collect the precipitate on filter paper, we drying it and weigh, and this considered the yield or residue of alkaloid obtained. To calculate the yield percentage or the yield of alkaloid, we subtract the weight of filter paper with alkaloid minus the weight of empty paper. We find the amount of alkaloid obtained. Amount of alkaloid divided by weight of sample, we find the percentage of alkaloids. For flavonoid, the quantitative determination by gravimetric methods can be achieved as the following. We add 50 milli 20% aqueous methanol to 2.5 gram of powder sample and allow it to stand for 24 hours at room temperature. We re-extract the powder sample with aqueous ethanol 3 times with the same solvent. Then we filter by using filter paper, near Wattman filter paper, size 42. So we transfer the sample into crucible and evaporate to dryness over water mass. So after drying, we cool the content in crucible by placing it in desiccator. Then we weigh the weight of crucible until the constant weight is obtained. To calculate the percentage of flavonoids, we use the following equation. Percentage of flavonoid equals the weight, W2, weight of crucible, W2, weight crucible with flavonoid, minus W1, the weight of empty crucible, divided by weight of the original sample, 2.5 gram in this example. Divided or multiplied by 100 to obtain the percentage of flavonoid. So, in brief or in summary, the quantitative determination of flavonoid require 2.5 gram of sample. We add or extract sample with 80% aqueous methanol and repeat it or re-extract 3 times. Then we filter the extract by plasma filter paper. We place the filtrate in crucible to evaporate the solvent on water bath. Then we cool the crucible indicator to remove the moisture, and we weighing the crucible with the extract. From the way of extract, we determine the percentage of flavonoids using equation الويت of crucible minus الويت of crucible with flavonoid minus الويت of empty crucible divided by weight of sample and multiplied by 100. We obtain percentage of flavonoids. For quantitative determination of saponin by gravimetric methods, this method involves or divided in several steps. In step 1, we determine the amount of powder sample, 5 gram, and we extract with 20% aqueous ethanol. In step 2, we heat the mixture on water bath and with continuous agitation, and then filter by filter paper, plasma filter paper size 42. The residue of the extract or the residue can be extracted with 20% ethanol and combine the two extracts. In the fourth step, we reduce the level or the volume of extract to 40 ml by heating at water bath and transfer the volume to separator funnel, and then we add diethyl ether with shake. At the end of this step, we have 2 layers, ethyl ether layer, and the other layer here, aqueous layer, can be clearly separated. In step 6, after we separate the 2 layers of diethyl ether and aqueous layer by separator funnel, we take the diethyl ether, which may expected to contain saponin, and we extract it with normal ethanol and wash it with 5% sodium hydroxide, sodium chloride solution. After that, we evaporate the extract in crucible with a non-wet. In step 7, we dry extract at oven at temperature 60 Celsius and rewait until the constant weight of crucible is obtained. To calculate the saponin present, the percentage of saponin, we need the volume equation. Here saponin percentage equal W2, the weight of crucible and saponin, minus W1, weight of empty crucible, divided by the weight of sample and multiplied by 100, we obtain the percentage of saponin. So, saponin determination by gravimetric titration involves using of ethanol and also addition of diethyl ether by separator funnel. We take the diethyl ether and then we extract saponin by addition of normal ethanol and sodium chloride solution. We take the extract and evaporate it on oven in crucible. Then we calculate the weight of crucible and sabonins and weight of empty crucible to calculate the percentage of sabonin present in blood. Determination of steroids by gravimetric methods can be divided in several steps. First of all, we weigh the sample of, uh, of the plant material. In this example, we take 5 gram and we hydrolyze or hydrolyzing the sample by addition of HCl solution because sometimes steroid occur as glyphosate. We add HCl to hydrolyze the glycosidic bond in glyphosate to obtain free steroid. After hydrolysis, we filter the solution by using filter paper and transferring the filtrate to separatory funnel to be extracted with acyl acetate. In step 4, recovery of acyl acetate layers, discard the aqueous fraction or keep for further analysis. In step 4, we take the acyl acetate fraction to step 5. In step 5, to acyl acetate fraction, we dry it on steam bath for 5 minutes and the concentrated extract is extracted by or concentrated by addition of amyl alcohol. The first step, addition of HCl hydrolyze the steroids, glyphosate. After hydrolysis, we filter the solution by filter paper. Then we add acyl acetate to separate the steroid from other sugars that may be present in sample. We take the acyl acetate and concentrate it in steam bath for 5 minutes at 100 Celsius, and then we add amyl alcohol. In step 6, after addition of amyl alcohol to acyl acetate fraction, the mixture becomes turbid. We place the mixture in crucible in step 6 and weighing it using cooling on desiccator until the weight reach the constant weight. We repeat the process of weighing until and take average weight in each experiment. To calculate the percentage of steroid in the sample, we use the following equation. Steroid percentage equal W2 weight of crucible and steroid minus Wn the weight of empty crucible divided by the weight of sample and multiplied by 100, we obtain the steroid percentage. The last example for gravimetric titration method is determination of limit or quantitative measurement of lipid. To determine the lipid content or total lipid content in plant sample, we need 5 gram of powder sample and place the sample in Sox-led extractor chamber, and we extract the sample with petroleum ether with refluxing for 3 hours at 50 Celsius. After 3 hours, we distill it off or remove petroleum ether solvent. Then we reweigh the sample holder and the extract or the residue which is considered as lipid. Calculate the percentage of lipid present in sample. We use the following equation. Percentage of lipid equal W2, which means the weight of sample holder and lipids, and minus W1, the weight of empty sample holder of extractor or succulent extractor. This value divided by weight of sample and multiplied by 100, then we obtain the percentage of lipid. For determination of secondary metabolite by volumetric titration method, we describe cyanogenic glycoside as an example. To determine cyanogenic glycoside by volumetric titration method, we follow the following steps. First step, we determine the weight of sample. We take 1 gram and place it in distilled water and allow it to stand for 2 hours. In step 2, distill the whole sample with 2.5 sodium hydroxide solution after adding tannic acid as anti-foaming agent. We distillate the mixture of water and sample after addition of sodium hydroxide 2% and addition of tannic acid as anti-foaming agent. In step 3, we take or we measure 100 ml of the filtrate which contains cyanogenic glycoside. We add 6 molar ammonium hydroxide solution and 5% potassium iodide to distillate with mixing and by titration with 0.02 molar silver nitrate and noting the turbidity of solution as endpoint for titration. So, to calculate the cyanogenic glycoside content, we use the following equation. Cyanogenic glycoside expressed in milligram per 100 gram equal the total volume in ml, which is the volume of silver nitrate used as titration solution or tetra solution multiplied by 1.08 and multiplied by exact volume of the sample divided by an equal volume in ml, volume of cyanuric glycoside plus silver nitrate, and divided by the weight of sample in gram multiplied by 100, we will obtain the cyanogenic glycoside concentration milligram per 100 gram sample. For determination of total phenol can be determined by using colorimetric method and using the reagent Pauline calcium reagent. We can quantitatively determine the total phenol present in sample. Firstly, to determine total phenol by this method, we need 10% of the reagent, Pauline thiocalcium reagent, and 2% solution sodium carbonate, and 1 ml of plant extract. We incubate this mixture at room temperature for 15 minutes. Then we measure the absorbance of the mixture at wavelength 765 nanometers, while we use gallic acid as a standard. Concentration of gallic acid 1 milligram per ml, and we determine the result from a standard curve of gallic acid standard, and the result obtained as expressed as equivalent to gallic acid equivalent here milligram per gram of extract, compound extract. To determine the total phenol using this colorimetric method, we follow this equation. Percentage of phenol equal 100 divided by W. W means the weight of sample analyzed, multiplied by AU, and AU means the absorbance of test sample at 365 nanometer, divided by AS, which means absorbance of standard gallic acid solution, and multiplied by C. C means concentration of standard in milligram per mil, divided by 1000, and this value multiplied by VF, which means the volume of filtrate analyzed, divided by VA, and volume, which means volume of extract used, and finally divided by D, which means dilution factor if applicable. At the end of this lecture, we summarize the following. Preliminary quantitative determinations means the use of physical and chemical methods to determine the quantity or the concentration of active constituent present in powdered plant sample. Quantitative determination is a useful tool for drug discovery and useful for standardization of herbal drugs, because it predicts the treatment or the condition to which the plant sample exposed, starting from cultivation until reaching the manufacturer. One of the disadvantages of general quantitative determination is the error result from interference between the active ingredient of plant sample. In the lecture, we talk about the different methods used in quantitative determination, including gravimetric titration, volumetric titration, colorimetric titration or assay, and calculation of yield percent. We speak about four examples for important classes of secondary metabolite can be determined using gravimetric titration, including alkaloid, steroid, flavonoid, lipids, and tannins. And sabonins. For volumetric titration, we speak about or describe the method determines generic glyphosate, and for colorimetric assay, we speak about determination of total phenol.